lesson about ratio and proportion. So at the beginning of this class, we have 3 new concepts to share. So first of all, ratio. So ratio is compared between 2 or more quantities. So sometimes you can say the ratio, what is the ratio between the boys and girls in this class, or what is the ratio between any of the 2 quantities. And then the second concept is conversion factor. So conversion factor is something to convert measurements from one unit to another. Like for example, how can I convert meters to kilometers? How can I convert minutes to hours? So that's the conversion. And we need a conversion factor to do this kind of conversion. And the last concept is rates. So the rates is something that measures how a quantity changes over time. So the most typical example is the speed, right? Speed is the distance travels over a certain quantity of time. And there's other rates. Anything that changes over time can be measured as a rate. Like for example, when we say the economic growth, the GDP growth rate is also a type of rates. So we start from the ratios first. So again, so ratio is compare the relative quantities of 2 groups. Later on, you will see that why we say it's relative quantities of 2 groups. So for example, if the class has 10 girls and 7 boys, then the ratio of, here when we say ratio, you need to specify the ratio of what versus what. So the ratio of girls to boys is 10 to 7. Okay, so this is first of all the verbally describing the ratio. It can be in this way. The ratio of girls to boys is 10 to 7. So this is how we describing this verbally. Now, how to describe this mathematically? We usually write the ratio of girls to boys is 10 to 7. We still say 10 to 7, but we can use the symbol to describing the ratio. And the other way is in the fractional form. So really, ratio is just equivalent to a fraction. Just a different way of writing them. But mathematically, their outcome should be equivalent between the ratios and fractions. And to note that why I'm saying that this is to compare the relative quantity is that if we go backward, if we know the ratio, you only know the relative relationship. You won't know the actual quantity. So it's relative quantity, it's not the actual quantity. For example, if let's say the ratio of girls to boys is 5 to 3, I don't know if there's 5 girls and 3 boys. So it could be 5 girls and 3 boys. It also could be 10 versus 6. It also could be 50 versus 30. Right? It's just like the fraction 5 over 3 can be also written as 50 over 30 or 500 over 300 as long as the ratio is the same. So that means the ratio will only give you the relative comparison, the relative quantity. It won't give you the actual number of the quantities. So this is something that you need to keep in mind. And of course, usually when we write out the ratio, we, like the fraction, will also want to write it in a simplified way. So even if I have 50 girls and 30 boys in the class, and I want to write the ratio, I would initially write this as 50 over 30, but I still want to simplify this. So 10 is a common factor. It can be simplified until 5/3. So eventually I will still say that the ratio is 5/3. I won't say that ratio is 50/30 because same to what we deal with the fractions. when we when we give the ratio, we also want to give the simplified way. Right. So for example, we can see more examples of how to simplify the ratio. It's just going to be the same as how we simplify the fraction. To simplify 2 versus 10, or 2 to 10, or 2/10. So this 2/10 or 2 to 10 have a common factor of 2. So if I divided number 2 to both number, I will get 1 to 5, right? You can verify this by writing this into a fraction, right? 2/10 equals 1/5. Or 1/2 to 1/3. I want to convert my ratio in representation of integers instead of fractions just to simplify this. So I want to cancel out all the fractions. So I can write this out in here, 1/2 versus 1/3. And then by simplifying this, you learned in the fraction section that you can multiply a common multiplier on both sides to eliminate the fractions. So here I can multiply the 6 on both sides. Then this becomes 3, this becomes 2. So eventually this is equivalent to 3 to 2, or 3 versus 2. Right? And same thing, I can do the same thing to simplify the decimal numbers in the ratio. Right? This can be first expressed as a large fraction, and then have 2 decimal numbers. I can convert them to integer by multiplying 10 on both of them. Right? Multiplying 10 means moving the decimal point one step to the right, so that I have 14/24. And then I can further simplify this by at least divided by 2. And it looks like there's no further common factors. Then the simplified ratio will be 7 to 12. Right, so these are the couple simple examples on how to simplify the ratios. Now we can go into a bit more complicated examples now. The ratio of cats to dogs in a pet shop is 2 versus 5. If there are 25 dogs, then how many cats do we have? Now later on I can show a more quicker way to solve this, but here let's start from the definition of the ratios. So if I assume that C is a number of cats, then C/25 is how we get this ratio 2/5, right? In order to get the ratio of cats to dogs, I'm using the total number of cats divided by the total number of dogs to eventually get to this ratio. Right. Now, if converting this all to the fraction form, it's then just equivalent to solve this equation, to solve C from this equation, right? Then C is 2/5 times 25. Then this gives you a factor of 5, so it's 10, right? The number of cats is 10. So there's actually another quicker way to show is that the ratio is 2 over 5. And I know that the number of dog is, the actual number of dog is 25. So it's 5 times from the ratio. So that means there's a multiple of 5 being simplified or being cancelled out when we get to this ratio. So equivalently, this 2 would also apply the 5 times. And that 5 times 2 will give you the actual number of cats, just based on the same ratio or same proportion that being increased from the ratio to the actual number. So this will be a even easier way. Let's see one more example. So I have a class that has ratio of girls to boys is 4 over 3, 4 or 4 versus 3, and there are 35 students in total. Then how many boys and girls in this class? Right. Again, first of all, there's a way that you can use the traditional way, or use the way that coming from the right beginning of the definition. You can let number of girls to be x, then number of boys will be 35 minus x, because there are totally 35 students. Then girls to boys, the ratio is 4 over 3. So converting the ratio to fraction, you will get x over 35 minus x is 4 over 3. And then you can solve x from this equation to get your results. So I'll leave the rest for you to practice. And there's another, maybe faster way, similar to the way that I showed in the previous example. If I know that the ratio is 4 over 3, even though I don't know the real number yet, but I will know that the relative quantity is 4 versus 3. So that means the relative total is 4 plus 3, which is 7. So this is the relative total, and this is the actual total number of the student is 35. So that means it's 5 times, because 35 divided by 7 is 5. So it's 5 times from the relative quantity to the actual quantity, which means when we simplify this ratio, at least one common multiple of 5 has been cancelled out. So which means if I'm enlarging the ratio, like remember in a fraction, a over b, it can be equal to a times n over b times n, as long as the number of n is the same on the both sides. It can be kind of enlarged proportionally, or enlarged with the same multiple. So same thing here, because the ratio it's just a different way to express the fraction. So which means you can also enlarge the relative quantity by the same multiple. So here, if I know that the total relative quantity is 5 times from the actual number, that means I can enlarge this by 5 times. I'll get 20 versus 15, right? And then I would know that this is the number of girls, because 20 plus 15 is just 35, and this is the number of boys. So in this way, you don't need to solve the equation. You can just quickly observing the total quantity versus the relative quantity. Okay, so far the ratio we have learned usually contains 2 quantities, like a ratio of boys over girls, the ratio of cats over dogs. Those are the comparison between 2 quantities. But obviously, we should be able to compare even more quantities. Right? For example, we call this multi-way ratio. Right, so this means that's the ratio that contains more than two quantities. For example, I can have 3 cats, 4 dogs, and 5 rabbits in the pet shop. Then the ratio of all the animals would be 3 versus 4 versus 5 for the 3 different pets, right? And this ratio is the multi-way ratio because you have more than 2 quantities. You actually have 3 quantities. And technically, you can have as many quantities as you want, as long as they follow the same way that to be derived from the ratio. And for the multi-way ratio or the multi-ratios, you can still apply the simplifications that we just learned as long as they have common factors that can be canceled out. For example, if I want to simplify 5 versus 15 versus 10, observing that number 5 is a common factor from each of the number. So if I divide every number by 5, I will get 1 versus 3 versus 2, right? And then there's no further common factors. So that I can simplify the multi-ratios using the same way. Right? And not only for rounded numbers, if my multi-ratio is fractions, I can do the same thing. For example, if I have fractions, well, first of all, let me convert them all to the single fraction. So that's 13 over 4 versus 17 over 4. If this is 3, 10 over 3 versus 17 over 4 versus 26 over 5. And here again, I want to convert the fraction into integer numbers. That means I want to cancel out the denominators by looking for their common denominator. 3 times 4 times 5, like remember what we learned to looking for the common multiples. So at least a common multiple is 60. So that means I can multiply 60 on each quantity of the ratio. So this will be this times 60 versus 17 over 4 times 60 versus 26 over 5 times 60. And then this gives 20. So it's 200 versus this is 15 times 17, that is 255. And the last one is 12 times 26, which is 312. And you can further check if there exists a common factor between these 3 numbers. Remember what you learned from the number theory chapter. You can do the prime factorization or whatever technique to try to see if there's any further common factors. At least here I don't see a common factor between all 3 numbers. So I think this is simply the simplest form. Okay, let's see another example with multi-ratio. So there is a bowling tournament. That pays out prizes to the top 3 players in the ratio of 5 versus 2 versus 1, right? And if the total price is 1,000, how much does every player get paid? right? So first of all, we know that all the top three players will get a prize, and the prize will in this ratio 5 versus 2 versus 1. So that means if the third player get 1 share of the bonus, then the second place player will get 2 shares of the bonus, and the first place player will get 5 shares of the bonus. And we also know the total bonus, right? So there's actually 2 ways, but let me use the most straightforward way, or maybe the simplest way. So first of all, the total shares of the price is 5 plus 2 plus 1 is 8, right? So even though I don't know the actual quantity of each price, I know the ratio, so that means I know the relative quantity. So the relative, so this is the relative quantity, right? The relative quantity is 8, or 8 shares. Now the first price would be 5 shares over the total 8 shares, right? Again, I don't know the actual quantity. I only know the ratio, or I only know the relative quantity. But by taking the ratio between the relative quantity, you will know the percentage, or the ratio of how much the first place player will get paid. So that's just 5 over 8. Then I also know the total price is 1,000. And then simply taking this multiplication will give you the dollar amount of how much the first place player will get paid. You can use the same way to calculate 2 over 8 1 over 8. Basically, this will give you the price of each top 3 player get paid. Let's see one more example. I have 3 type of seed. I have lots, blitz in the bag. The ratio of blots to bleeds is 3 over 4, and the ratio of bleeds to bleeds is 5 over 6. So what is the ratio of blots to bleeds? Okay, in this example, I know the ratio of each pair, and I want to know the ratio of the 2 unknown pairs. First of all, blots to bleeds is 3 over 4, and bleeds over bleeds is 5 over 6. And I want to know blots over bleeds, right? So first of all, I can convert these two ratios into one multi-ratio, because the common quantity between the 2 ratios is the quantity, or the relative quantity of bleeds. So that means if the relative quantity becomes the same, then I can link the 2 ratios into one multi-ratio. For example, if this one I multiply this by 5 times, the ratio can be written as 15 over 20, right? In this one, if I'm multiplying or increasing this by 4 times proportionally, the second ratio can be written as 20 versus 24. now you have the same quantity 20 and 20 here, which means the ratio between the three quantities is the first two is 15 versus 20, and then the last two is 20 versus 24, right? And because now I convert the 20 or the relative quantity of bleeds into the same quantity, then this can be linked or can be written together. And then if we already have the ratio between this all three quantities, then of course the ratio between any two quantities can be taken out. For example, bloods versus bleeds will be 15 versus 24. And you can, I see a common factor of 3, so you can at least simplify this to 5/8. And next we're going to review more concepts or examples of proportions. So we actually, in the previous examples, when we see how to convert or transfer the ratios, we already get to know some concepts of proportions. Basically, if two ratios are equal, then we have a proportion. So for example, if I know that in order to make 10 ounces of a special soup, I need 8 ounces of milk and 2 ounces of chocolate. Okay. This first gives you a ratio of 8/2, 8 versus 2, right? Or 4 versus 1 of milk to chocolate, right? So then what happens if I want to make 50 ounces of such soup? How much milk do I need and how much chocolate do I need? So this is actually using the concept of the proportions. Like, remember, we already had this in our previous examples when we're converting the ratios. We can enlarge the ratio just as how we did for the fractions. We can enlarge that by multiplying the same numbers on each quantity. So for example, 4/1 can be enlarged to, by multiplying 2, I can get 8 versus 2, or by multiplying 5 times, I will get 40/10, 40 versus 10. Now, here 40 plus 10 is just equal to 50, so I can use this way by enlarge my ratio proportionally to eventually get my relative quantity, right? All these are relative quantity. To eventually get my relative quantity equals to the actual quantity that I'm looking for. And this directly tells me that I need 40 ounces of milk. I just need 40 ounces of milk and 10 ounces of chocolate to make my 50-ounce soup. So this is how to solve a question that contains ratios by increase the ratio proportionally to get your relative quantity and to be same as the actual quantity. So for example, if the exchange rate of to euro is $1 equals 0.6 euro. Then if we need 300 euro, how much dollar do I need to convert that? Right, so first of all, here I know that dollar to euro is 1 to 0.6, right? This is the ratio between dollar to euro. And I can first just simplify this a little bit for later calculation. So first off, I can multiply a 10, so to convert decimal into integer. And then I'm looking for the common factor to further simplify this to be 5 versus 3. So that means the dollar to euro ratio can be expressed as 5 versus 3. Now I need 300 euro. How much dollar do I need if I let x equal to number of dollars? Then my x versus 300 should be the same ratio as this exchange rate 5 versus 3. Right? You can solve this equation, or you will directly see that the actual number is just 100 times higher than the relative ratio. So that means x is 500. So I need $500 in order to convert them into 300 euro. Right, so this basically solved x from this equation. Let's see one last example. So for every 3 degree, rise in temperature, the volume of a certain gas expand by 4 cubic centimeters. Now, if the volume is 24 cubic centimeter, the temperature is 32 degrees. Now, question is, what was the volume of the gas when the temperature was 20 degrees? So first of all, do we have a ratio here? From the first sentence of this question, we have a relative ratio between the change of temperature versus the change of volume. And then the second sentence tells us one of the states that when the volume is 24 cubic centimeter, temperature is 32 degrees. Then by knowing the ratio and one certain condition, or the question is asking, then how about when the temperature was 20 degrees, then what is the volume? So let's write out the ratio first. So the temperature change versus volume change is 3 degrees, right? Every 3 degree rise, the gas expand by 4 cubic centimeters. So it's 3 versus 4. And in temperature, let's say T1, when the temperature is 32, the volume is 24 cubic centimeter. Then the question is, when the temperature is 20, what is the volume? Okay, so we know the ratio. We have two states from state 1 or from status 1 to status 2. How the volume is going to change. So first of all, what we know from both states is that we know the temperature change. Delta T, where the temperature change is from T1 to T2, that is 32 degree minus 20 degree, that's 12 degree. So at least I know that the temperature between these two is 12 degree. Then if I know the temperature change, every 3 degree will cause will cause a 4 cubic centimeter volume change. So the volume change, x volume change, should follow the same ratio, right? Then I'm just solving this volume change from the equation. I get x equal to 4 over 3 times 12. That is 16 cubic centimeter, right? So based on the known condition, based on the ratio, I know that this 12 degree change or 12 degree decrease will cause 16 cubic centimeter volume decrease. So then the volume at 20 degree is 24 minus 16, which is 8 cubic centimeter. Right, so this is how you take the known condition of the change in terms of the ratio, in terms of the relative quantity change, to derive the volume change given the known temperature change.